Welcome to today's session, which is about how to use feature lines and grading tools for the design of detention ponds. We will follow these steps in order to achieve the objective. We will gather the watershed data for the site, pre and post development. We will estimate the time of concentration for the water to come through to the detention pond. We will also gather information about the soils of the site. We will compute a runoff curve number. Then we will size the detention pond. Also select the outlet control structure. Then we will do a final routing of the pipelines. And then we will then prepare a report. But for this presentation, the focus will be on the detention pond design. My name is Loyiso Toi. I'm a civil engineer at Tabisa Consulting. This channel is for you, and the topics we cover come directly from questions we get on a daily basis. So if you like what you see, please subscribe to the channel. We also welcome your comments on this video. If there are other topics you would like us to cover, please get in touch by leaving a comment. With that said, let's dive in. To give a bit of background, we've been asked to perform a drainage study so that we can size a detention pond, inlets and stormwater network for this project. We will start with a 2D polyline, which we will convert into a feature line. Once we open this dialog box and we select this polyline, it prompts us for some settings for this feature line. One of the settings is the site, which we will create a new site that we'll call pond and curb. We keep feature lines inside sites because when feature lines are in the same site, they interact with each other. If two feature lines in the same site cross, they assume the same elevation at that crossing point. We will pull elevations from the existing surface. Also, as you will also assign a style to this feature line, I just want to assign that one of green so that it's visible. And we click OK. And as you can see, it's now pulling the levels of the feature line from the existing surface. There is our feature line. Now we have a feature line, which is essentially a 3D polyline with a few extra options. Click on it. And if we just go onto the editor, you now can see that each vertex has got a separate level of its own, and also as we hover above the feature line, we are able to see the gradient. Okay, we can get out of this. If we now pick on the level editor, and now you can see all those levels of the vertices. If we pick on all of these vertices and assign to them a level of 1580, remember this feature line represents the top water surface of our pond. There we are, we've got all our levels of our feature line at 1580. Now we will use other feature line tools. We launched the grading creation tools, and we create a grading group. The group name will be, we will create a group name, same pond and curb. And we will select the automatic surface creation And the tessellation spacing we will leave at 5 meters, and we click OK. OK. We're happy with that. Now we have specified our target surface as the existing ground. We'll now grade this feature line at a given slope for a distance of 3 meters. So if we create that, we say create grading, select, says we're applying, yes, we're applying for the entire length. I want a distance of 3 meters. Now it wants the slope. I want there we have created our grading. Just want to save that. And then we can go and have a look at it in Object Viewer. Okay. There is our grading. So our pond is beginning to take shape. Let's look at that realistic. Okay, let's look at which other one shows nicely here. I think it's a realistic. No, it's a wireframe. Yes. So we're beginning to see our pond shaping up. Okay, we now will create other gradings using the other grading criteria sets. We now grade for a distance of 10 meters at 1:2. So if we come up here, and again we select that, we create the grading, we select the feature line. The distance will go 10 meters at a slope of okay. That does that. Also now what we'll also do now is to create an infill on our pond. That's the area that will be done an infill on. So there's our pond. Let's save that before we have a look at it in Object Viewer. Yes, now we can see our pond is looking nice. We also notice that we've got some flat areas here, but we can address those at a later stage. But yes, I think it's looking nice. Let's try it on realistic. Our pond is looking good. So we've created a shelf, and then it goes a bit steeper after that. That is our pond. Okay, we can close and get out of that. From the top water surface, we want to grade up at a 1:3 slope. For this, we're going to use the relative criteria. I want to come and use this one, and we will set this. We will grade with this. We'll create the grading. It wants us to select the feature line, and we're going to grade it. Oh no, before, yes, we do grade it to the outside, but we will not grade it for the entire length. I want to grade from there, accept that, to there. And we will set the level at 2 meters. Slope is 1.3. As you can see now, it's created that that BAM. Okay, now the next thing we want to do is to create a top on this. Is to create a top. We'll create it here, and we'll go the whole. I want a distance of 1.5. I want the grade at I want it at 1%. Okay. So I've created that top. Okay, now what we want to do is to create our spillway, which will be in this gap here. For this, we're going to use the spillway criteria. We create the grading. We're selecting that feature line on that side. We will do it between there. Must accept that. And between there, I accept that. We will go for a distance of 1.5 meters. Gradient will be 0. Now we want to create a transition. When we define two gradings that have a gap, then we need to build a transition between them. We can use the transition tool to close that gap. We can create a transition, and we select this feature line, and then we select the gap, and see that it closes. We can select this feature line, and we select the gap. Now we see that it has closed up that gap that existed there. Okay, let me just save this. I also want to just delete these lines that I had used to help me create this spillway. Okay. Let's save that again. Just want to try and have a look at this now in Object Viewer. Let's see how it looks. You can see our spillway there, but let's just see if we can see it. Wow, this is beautiful. That is beautiful. That is our spillway on our pond. So once the water inside here starts to rise above this level of the top water level, it will overflow through that spillway there. Just want to have a look at this wireframe. Yes, it is a beautiful pond. It is a beautiful pond. Okay, let's get out of that. Now that we've got our spillway done, we can now create a grading to surface from this top of the berm. So again, we come and we launch our grading tools, and we select this one, surface 3 to 1, and we create our grading. And now we've got to come and select the feature line. We're applying it onto the internal length, onto the entire length. If we're in cut, I'd like to go 1:2. 1:2. If we're in fill, we'll go 1:3. Okay, so there is our pond. Let's close this guy. There is our pond with our spillway. Okay, let me save that. I would never want to have the thing crashing on me. Okay, let's see if we would be lucky at all with the object viewer of our beautiful pond. Okay, it's looking beautiful. There is our pond. Even I like the look of our spillway here. I like the look of our spillway. Close the wheel. Okay, there's it. I like the look of that. I like the look of that. Let's go conceptual. That doesn't give us a beautiful look. How is that? How is that? Tell me you like it, because I do. That is your pond. In order to calculate the volumes of our pond, we now need to create a surface where we will put this top water line. So if we can put it, we're going to add it to a new surface that we're going to call pond 1 top. Okay, and we're done. Okay, we're happy with that. Let's give it a label here. Okay, we're happy with that. Now that we have done that, we can now check our volumes, and we will create a new surface here, which we will call pond 1 volume. We're happy with that. So in here we will use our base surface as the pond and cap surface, and we will use our comparison surface as the pond 1 top, which was where the top water level was. Now we can see that our volumes are 31,165 cubic meters. Now we want to calculate the stage storage of our pond so that we can then export it for further analysis. To do that, we're gonna come in here and we do the stage analysis, storage stage analysis. Call this pond 1. We will call that, so I'll just call it pond 1. Detention pond. Okay, then we will just have to define the basin. Basin name is pond 1. We'll create that from surface contours. Okay, define it with that. Okay, so now that has been defined. Okay, we can save that table. Okay, if we can insert it in our drawing. Just wanna put it just outside the boundary. Okay, here is our storage table. Let me see. No, I don't think I want to move it. So that's our stage storage, which shows you that at the various elevations, what is the kind of areas and also the average volumes. We hope this video has shown you how you can model your detention ponds in Civil 3D using feature lines and grading tools. Feature lines are 3D polylines on steroids, in that they can also be used with assemblies to model retaining walls as well as grading parking areas. Feature lines are the king of the grading world. They act as break lines, boundaries, and corridor controls to handle even the most complex of grading conditions. If there's other topics that you would like us to cover, please get in touch with us. You can email me or you can leave comments on the comment section and we will certainly consider those comments of yours. Thank you very much.